All right, so today we're talking about exponential growth and decay, just building off of what we talked about yesterday. So exponential growth, we talked about yesterday was figured out by B, and we don't have a B on our paper here. So remember our equation is y equals a times b to the x power. And for growth, we're talking about a times this parentheses to the exponent. So on this equation, when we're talking about that, usually the exponential growth and decay is talking about time. And so we are talking about t for time. And then a is the same. A and a, they're the exact same. So a, the only difference here is it does mean the y-intercept as we talked about yesterday, but it also means initial amount, so starting amount. And then b, remember we talked about if b was greater than 1, then it was considered the rate, or it was considered an exponential growth. So our growth factor is the whole value of b, but to figure out the rate of growth, it is whatever 1 plus r is. So the r is the rate of growth. It's usually a percentage. We just need to turn it into a decimal. So for instance, if we're talking about 7%, if we were to turn that into a decimal, remember we take our decimal and we move it 2 spots from here to 1, 2, and we would put it here and add a 0. So 7% is really 0.07. If I asked you for 25% as a decimal, then that would be 0.25. If I asked you for 110%, which is also an option, then that would be 1.1. Okay? Again, that value is then added to 1 to get what is raised to the exponent. So an example, we have example 1, we're looking at a word problem. We have the inaugural attendance of an annual music festival is 150,000. The attendance increases by 8% each year. So increases immediately tells us it's a growth function. So we need to write an exponential growth function that represents the attendance after t years. So our equation is y equals a parentheses 1 plus r raised to the t power. So again, I am just using the information or the equation that I had. So now I'm going to plug in what I know. It says the inaugural attendance is 150,000. Inaugural means first, so it would be our initial amount. So we're going to plug in the 150,000 where A is. And then the 1 plus is the same for all equations that are a growth function. And we need to figure out what R is. R is the rate of growth. Well, it increases by 8%. So if I want to turn 8% into a decimal, then that would be 0.08. So that would be my R. So I'm going to do 1 plus 0.08 raised to the t power. So this is the equation. Now you can either write it like this, or you could simplify the parentheses and have y equals 150,000 parentheses 1.08t. That is also an option. These are the same. So that's the answer for A. B says how many people will attend the festival in the 5th year. So this isn't going from like 2000 to 2010, and that would be a change of 10 years. This is saying from the 1st year, we need to go to the 5th year. So that calculation is a little different. If on the 1st year, they had 150,000, but that's my y-intercept. So really here, we have t and we have y, and t is 0, and my y-intercept is 150,000. But that's my 1st year. So then my 2nd year would be when t is 1. My 3rd year would be when t is 2. My 4th year would be when t is 3, and my 5th year would be when t is 4. Again, not the case when we're talking about 2000 to 2005 or 2000 to 2010, but it is the case when we're talking about the 1st year versus say the 10th year. So for this, t is 4. So I'm going to plug in where t is. I'm going to plug in the number 4. So for part B, y equals 150,000 times 1.08 to the 4th power. So then we're going to type that into the calculator. So we're going to go to Desmos and we're going to type in 150,000 parentheses 1.08 close parentheses and raise that to the 4th power. So we're going to type it in like this. And so we get 204,073.344. So I'm going to write down the whole thing, even though that's not what it's asking for exactly. So this is what Desmos spit out. Now the computer's asking for people, and when it's asking for like a population or something, it usually wants you to round. This one says round to the nearest 1,000. Not thousandth, not a decimal, but 1,000. So that would be the 4th place. So because it's a 0, we would just make this 204,000, and that would be my answer for B. Now, if it said to the nearest 10th place, which is also something that you'll see, then if I were to round this to the nearest 10th place, that's 1 spot after the decimal. So then I would look at the 4, and that would just be dropped. So this would be rounded to the nearest 10th, because you're also going to have things that have to be rounded to the nearest 10th. Okay, so there's that. So then we have some other problems. So you may see a problem on your paper that looks like this. So I'm going to do another problem off to the side. H of t equals 175 parentheses 1.028 to the t power, like this. And then it's going to ask you some questions. So the first question it would ask you is, what is the initial amount? So initial amount, we would say, looking at the equation, it's where A is. So it's this first spot outside the parentheses. So my initial amount is 175. Now, the second thing it would ask you is, what is the rate of growth? So what is the percentage of growth? And so when we're looking here, again, this is y equals a parentheses 1 plus r to the t power, and it's just asking for r. So we need to take our value and we need to take 1 away, and we end up with 0.028. Well, 0.028 is not my answer because I need to change it into a percentage. When it's talking about rate of growth, it's asking for the percentage of change. So 0.028, although it's the answer, it wants that as a percentage. So we would move the decimal 2 spots that way, ended up with 2.8% as my rate of growth. Now the last question says, what is it when the t equals 5 years? And round to the nearest hundredth. So we would take our equation and we would take and plug this into the calculator. 175, open parentheses, 1.028 to the 5th power. And we would type that in. So let me get that pulled up on Desmos. And so here we are, we end up with 200.91. Again, rounded to the nearest 10th is 1 spot after the decimal, so the 0.9. And that 1 says we just drop it. So it's 200.9 is what I would write as my answer. Okay, so now let's flip it over and let's look at exponential decay. Exponential decay, the thing that's different, the initial amount's the same, it's A. The rate of decay, the thing in parentheses, is 1 minus R, because remember, your R value, or your decay says that the parentheses, right, the B value, is going to be between 0 and 1. So we would take the rate from 1 to get me that decay factor. So if we were to ask you a question like this, say h of t is 1250, open parentheses, 0.865 t. All right, so if it asks you the initial amount, it's asking you for the number in front of the parentheses, the first number, which would be 1,250. If it asks you for the rate of decay, then we're looking at 0.865, but it's from 1. 1 minus what equals 0.865. So 1 minus what number equals 0.865. Well, to get that, you can take 0.865 from 1 and see what that equals. So if I'm on my calculator, and then I would take 1 minus 0.865, and that leaves me with 0.135. So 0.135 is the rate as a decimal. We would need to change it to a percent. So again, move the decimal spot 2 times this way, which means it would be 13.5%. So my rate of decay is decreasing by 13.5%. All right. So another example would be if we had 4,750 parentheses 0.6 t. Your initial amount here is 4,750. And your rate of decay, again, 1 minus 0.6 is 0.4. Change that into a percentage. So 0.4 becomes 40% is my rate of decay. Okay. So now we have exponential growth, exponential decay. One of these is growth or decay, or it could be neither. So if we are multiplying by the same number every time, then it's an exponential function. If we're adding or subtracting, if we're dividing by the number, then it's not an exponential function. So if we're looking at these two things, determine whether each table represents a growth or decay or neither. So to get from 270 to 90, you might think, what's happening there? It's either subtracting 200 or 180 from 270 to get the 90, or it could be like, okay, it's dividing by 3. But we want to see if it's multiplying by the same thing. So dividing by 3 is actually the same as multiplying by 1/3. So we're going to say multiply by 1/3. And so then 90 times 1/3, does that equal 30? Yes, it does. And then 30 times 1/3, does that equal 10? Yes, it does. And then you'd be able to keep predicting like the next values. Again, x always has to be adding by 1 here. That's like our time. So this is going down. This is a fraction. It's between 0 and 1, which means it's an exponential decay. So then we look over here. Our x values, we are adding by 1 all the time. And then we need to see what's changing from here. To get from 5 to 10, are we adding 5? Well, no, it doesn't work to get from 10 to 20. So from 5 to 10, we could also be multiplying by 2. And then that does work. 10 times 2 is also 20. 20 times 2 is also 40. So we're multiplying by 2. And so this is greater than 1. So that means this is an exponential growth. You can also look at the y values, and if they're increasing, then that would be a growth, and these are decreasing as a decay. You still have to do the calculations because they still have to be multiplied by the same numbers. All right, interpreting word problems. So first we have to determine whether these are growth or decay, and then we have to identify the initial amount and kind of what it means. So this function, we have y equals a times b to the x power, right? And so a is 0.5 and b is 1.07. Well, b is what tells us if it's growth or decay, so this one is an exponential growth. It says the initial value is a, so that's 0.5. So initial, we're going to write 0.5. And it says the rate that it's going to grow is 1.07. That's our growth factor. But we need to find the rate, which we need to subtract the 1. So it's 0.07. As a percentage, 0.07 is 7%. 7% increase. Now, if we're putting it in terms of the word problem says the value in dollars of a baseball card T years after it's issued. So we're talking about baseball cards and purchasing a baseball card. So the purchase of the baseball card is 50 cents, right? 0.05, that's the initial amount. So 50 cents is how much our baseball card costed originally, and then it's growing at 7% each year. So now the next one is B. We're talking about y equals 128 times 0.5 to the x power. And so if we're talking about our A value, so is this a growth or decay? In the parentheses, it's 0.5. That's a number between 1 and 0 and 1. So it's an exponential decay. So then we need to figure out if the initial value, so initial value is what's outside the parentheses, so it's 128. And then we need to talk about the rate of decay. So the rate of decay as a decimal is 1 minus 0.5, which is 0.5. That's the only one where the number, the rate of decay and what you see is the same. And so 0.5 is our rate of decay. As a percentage, 0.5 is 50% decrease happening each time. So when we're talking about the word problem, this is saying it represents the number of players left in a video game tournament after X rounds. So that's saying we started with 128 players, and then we rolled through 50% decrease each round. So the second round would have 64 players. The third round would have half of that, which is 32 players. The next round would have 16 players, and so on and so forth, until you have the winner of the tournament. So things to remember today. A is the initial value, and it is also the y-intercept. B is telling me whether it's a growth or a decay. B cannot be 0. Remember, it can be between B can be between 0 and 1, but it doesn't include 0 or 1. Or B can be greater than 1, but again, doesn't include 1. So B can't be 1 and B can't be negative, are things that you know. Other than that, A can be negative. That's what flips it over the x-axis. What else? You're also talking about linear functions. So if, for instance, it's set up as y equals a times bx, then this is exponential. If we're talking about y equals mx, like being multiplied, and the x is not in the exponent spot, then this would be a linear function. If we're talking about y equals x squared, or x to the third, or x to the fourth, then that's not exponential because x isn't in the exponent spot. It's a number, and that would be quadratic. So today you're going to work your way through 6.3. If you finish that, you could start on 6.4, but we're going to have all day tomorrow to work on that as well in class. And the big ideas assignments, both of them, 6.3 and 6.4, are due on Thursday. There is no work that needs to be shown for these. You're basically just looking at the problem and typing it in. All right.